Today, I am going to show how to automatically fix bugs in large-scale real-world programs using semantic code search. Given a buggy program and a set of passing and failing test cases, automated program repair techniques attempt to automatically produce patches for software defects. Since all they know about the program are the test cases, they generally tweak the program in different ways until all test cases pass. However, this approach may result in low-quality patches that pass all the test cases but do not fix the underlying problem. Semantic search-based repair approaches take advantage of the redundancy of human-written code and search for semantically similar code snippets from other repositories to patch the program at a higher level of granularity, which is shown to generate higher quality patches on small programs. Here we introduce SOSRepair, which is the first semantic search-based automated program repair approach that scales to large programs. Using a novel expressive encoding approach, SOSRepair creates a database of candidate code snippets and their semantic encoding. It then captures the intended behavior of the buggy code. Next, taking a code snippet from its database, SOSRepair creates a novel, scalable semantic search query that uses an SMT solver to check whether the code snippet can be used to fix the bug. If the solver finds the query satisfiable, SOSRepair generates a patch and runs the test cases. We evaluate SOSRepair on a benchmark of real-world defects and show that SOSRepair can generate very high-quality patches, such as the one shown in this example. SOSRepair generates patches for 22 of the 65 defects, 9 of which have 100% quality. Overall, SOSRepair shows that semantic search is a promising approach towards generating high-quality patches. For more information, check out our paper published at TSE in 2019. Thank you for your attention.